Very good morning, children. Children, today we'll start with lesson number 3, that is properties of natural resources. Okay, children, before that, let us recall what we did in our earlier standards. Fine. Which are the gases present in our air, children? Yes, nitrogen, oxygen, carbon dioxide, some inert gases, right? Why air is called as a homogeneous mixture? Yes, because it contains several kinds of gases, right? And what are the uses of various gases in air? This all, children, you have learnt in our earliest standards, right? So in this chapter we are going to see more about the properties of natural resources, means air, water and land. Fine. First we'll see about properties of air. Children, we all know that air is all around us. Yes. But although we cannot see it, we can feel the presence of air. Right? Similarly, when we all inhale, okay, the air is taken inside the body, right? With the help of which organ, children? Nose, right? And sometimes mouth. Yes, children? Okay. Now, directly come to figure number 3.1, children. Yes, this is a simple activity. What you have to do in this activity is that tie two rubber balloons of same size at the two ends. Okay. See to it that the stick remains horizontal. Now remove one balloon, inflate it and tie it again in the original position. So, children, what do you all observe? Does the stick remain horizontal? No. The stick goes down on one side, right, children? This means that air has weight. Fine. We all know that air is a mixture of gases, right? So, children, the first property is that air has mass and weight. Fine, children. Next. Here is a next activity. Take an injection syringe without needle. Pull its piston and observe it as you do so. You can see it in the figure, which is the piston. Yes, the back side of the syringe is the piston, right? What you will observe, the piston can be pulled out easily. Okay, and it then remains in that position even if you let it go. Now close the inlet hole of the syringe tightly with your thumb. Fine. Pull the piston and let it go. Now, children, what you will observe? You will observe that force is required to pull the piston, right? Okay. See here, like this. Figure 3.2. Yes. The molecules of the gases in the air are in constant motion. When these molecules strike a body, they create pressure on that body, and this is called as atmospheric pressure. Fine, children. The first property of air was air has mass and weight, and the second property is it has atmospheric pressure. Okay. And children, from this we can infer that atmospheric pressure is same in all the directions. Fine, children. Here is something you don't know. Under ordinary conditions, atmospheric pressure at sea level is about 1 lakh 1400 newtons per square meter. and it can be measured with the help of a barometer. Fine. And as we go higher above the sea level, atmospheric pressure decreases. Fine, children. Children, here is a little fun for you all. Place a piece of cardboard on the mouth of a glass filled completely with water. Holding the cardboard firmly in place with one hand, invert the glass quickly. Take your hand away from the cardboard. What will you see? Will the cardboard fall? No. The cardboard will not fall down. Fine. Now we'll see about scientists. In 1726, a Swedish scientist, Daniel Bernoulli, put forth an important principle that the pressure of air decreases when its velocity increases, and when the pressure of air increases, its velocity decreases. Fine. If a body is moving through air, the air pressure decreases perpendicular to the diameter of the motion, and the air in its surroundings flows rapidly from higher pressure to lower pressure. Fine, children. Children, in this chapter we have a lot of activities, so you will enjoy this, children. Here is another activity to see the effect of air pressure. What you have to do is that take some water in a plastic cup and hold a straw upright in it. You can see the figure, right? Hold a small piece of another straw near the upper end of the first straw and perpendicular to the straw. Okay? Now you have to blow hard through the small piece of straw. What will you see? You will see a fountain of water. Okay? And why did this happen, children? On blowing through the straw, the air at its open end is pushed away, and hence the pressure of the air at the opening goes down. As the pressure of the air near the upper end of the erect straw becomes less than the atmospheric pressure, the water in the cup is pushed from where the pressure is higher to where it is lower. Is in the upward direction, and the water comes out in the form of fountain. Okay, understood, children? This straw fountain works on the Bernoulli principle. Fine, children? Yes. Now, children, see figure 3.4. Yes, what you all can see here? You all can see that there is a glass, and in that glass ice cubes are there, right? And one more thing you can see is that water droplets are formed on the outer part of the glass, right? Due to the ice cubes in the glass, the air surrounding the glass cools down. As the water vapor in the air cools down, it condenses and gets transformed into water. Yes, children. It is this water that gets collected on the outer surface of the glass. The level of humidity is different in different places. Fine. And it is determined by the capacity to hold water. During the night or dawn, when the temperature of air is low, its capacity to hold water is less. Okay. In the afternoon, when the temperature of the air is high, the capacity of the air to hold the moisture increases. Fine, children? Next, see figure 3.5. And besides that is next to that, see, we come to know from all above activities that air has properties like occupying space, having a certain volume, having mass and weight. Right, children? Up till now, we saw these properties of air. Air is a mixture of very fine particles of some gases, dust, smoke, and moisture. When rays of light fall on these minute particles, the particles spread the light in all the directions. So this property of air is called as scattering of light. Okay, children. One more property we saw now, scattering of light. Fine. Now temperature regulation. How is the temperature regulated on our earth? The earth receives energy from the sun. Yes. This energy is reflected by the earth in the form of heat. Yes. The constituents of air surrounding the earth, such as water vapor, carbon dioxide, absorb a part of this heat and give it to other constituents of air. And as a result of this, the surface of our earth remains warm, and therefore it is suitable for all the living world to live on earth. Fine, children. Children, what would happen if there would be no air on earth? If there will be no air on earth, the average temperature of earth's surface will go very low, and we all will not be able to survive in that atmosphere. Okay, children. Next, transmission of sound. Children, this was all about air. Now we'll see about sound. All the sounds that we hear reach us through the surrounding air. The density of air changes due to the change in its temperature. In winter, the density of air increases. We can hear the whistle of a distant train clearly early in the morning in winter. Air is useful as a medium for transmission of sound. Fine, children. Then we'll see about properties of water. Water occurs in three states, that is solid, liquid, and gas, right? Water occurs in the liquid state under ordinary conditions. Water is a fluid substance, right? Water does not have its own shape, but it has its own volume. It can pass through small holes or seep through very small gaps or cracks. Right, children? These are the characteristic features of water. On pouring water in an oil-cladded dish, water does not spread, but it forms small round clumps or drops. Right? Why this is happening, children? As water freezes to form ice, it expands and its volume increases. On freezing, the volume of the water, it will be low or high, children? Yes, it will be high. Okay. Next, there is another activity. Take a bucket of water, drop many different kinds of articles in it. Make separate lists for those articles that sink and those articles that float. Fine, children. Take some water in a pot and add few pieces of ice to it. Observe what happens. Why do we see that ice floats on water? Ice is lighter than water. When water freezes to form ice, it becomes lighter than original liquid. Fine, children. Then water freezes, that is, it transforms into the solid state and volume increases. Therefore, the density of ice is less than that of water. And children, that is why ice floats on water. Fine. Next is, what is the interrelation between density, mass, and volume? Density is equal to mass upon volume. Mass is measured in grams and volume in cubic centimeters. Hence, density is equal to gram upon cc. Okay, children. Next, we'll see the last topic of this lecture, that is anomalous behavior of water. Children, usually when the temperature of the substance is lowered, its density increases and the volume decreases. Okay, but water is an exception. Keep a glass full of water in the freezer for 5 to 10 minutes. Then take it out and observe it carefully. From which part of the glass does the water first start freezing? When water at normal temperature starts cooling, its density increases like that of the most liquids. However, its temperature falls below 0 degrees Celsius. This means that the density of the water is maximum at 4 degrees Celsius. Fine. If the temperature of the water is lowered below 4 degrees Celsius, it destroys microorganisms. It decreases and our volume increases. And it means that water expands when the temperature decreases below 4 degrees Celsius. This is what is called as anomalous behavior of water. Thank you.